Good evening, students. There is one more question is asked in somewhere in either in a gate or something, that what is the addressing mode. So today we will talk about the addressing mode. That what is the addressing modes? Okay, because whenever we are talking about any type of thing, it may be either processor or controller or something. We normally deal with the instruction. An instruction is normally called as a command which actually given to perform any tasks by the processor. Okay, so now come to the point on here. What do you mean by addressing? First we will come to the point on here is that by one example, suppose this is a one boy is there, and his name is, suppose for example, is Shubhanshu. Okay, and I am instructor. If initially this is instructor, if the instructor doesn't know the name of this fellow, that what is the name of this one, he will call him just like you can say by saying hello. Okay, so this is the first way that how he will communicate with the student. So this is, I am calling, this is the first way of addressing this student. Okay, if the instructor knows, if the instructor knows the name, then he can directly call him by his name is called Shubhanshu. Okay, so this is the second way. This is the second way. So this is the first way and this is the second way. So now my point here is that there are two alternatives way. If you don't know the name, you will directly say hello only, and he will give the reply of this hello. Or you know the name of this boy, you can directly say Shubhanshu, and Shubhanshu will give the reply. Okay, so now come to the point on here. We have seen that there are two various ways of addressing anybody in normal life. Okay, so similarly, when we talk about the any instruction, this instruction is composed of two different parts. The first one is called opcode and another one is called operand. Okay, the opcode says what type of operation you have to perform. We can say type of operation, and on which the operation to be performed. Okay, so we can see that each and every instruction, for example, this is your processor. I normally talk about the generic processor. So this is your processor, and this processor is accessing some instructions written on some external memory. This is your external memory. Okay, so may possible that you are writing some code. So code is written just like this one. That may possible that, for example, if I say you are having the one instruction just like MVI A, 32. So this MVI A is opcode, and this is the operand. And how we normally store this one? Here in this memory is always recognized with some address. So I am having one address like this. So this address is, for example, this is 3000, this is 3001, like this. Now we can see that here at this initial memory we can understand some hex code of MVI A, whatever the hex code. So I am right here MVI A, and here I will store 32 because we directly store the hex code on here. So here I am not considering the hex code for MVIA. Whatever the hex code you can assume on here is that. So this is the way we can store the data into this one. So we can say on 3000 the MVA, the hex code of the MVIA is stored, and into 3001 the hex code of 32 is stored. Now come to the point on here. This microprocessor will instruct to this address bus that go on this address, okay, and take out this data. So for example, this data bus is connected. So this is your data bus and this is your address bus. And according to the type of the control signal, for example, the type of control signal I will send here is memory read bar. Okay, so when the processor will send this address on the address bus, so address bus, we can think it will go, this address bus is here, so this address bus will take the address of 3000. Okay, now next step is that this is step 1. Step 2 says that you have to send some control signal. So I am sending a control signal. Microprocessor will send a control signal in the format of memory read bar. And another type of thing is that your data bus will actuate, and finally the data from this external memory will be flow on this one. So this MVIA, the hex code of MVIA will be travel on this in this direction. So this is your step number 3. The basic way is that we can say your instruction is having 2 parts, MVI A, 32. So normally this operation says that you have to store a data, you have to store this data into the accumulator A. This is the meaning of this one. Okay, so now the addressing mode normally defined is the way that how any instruction will try to access the data, because the data is stored either on the memory or some peripheral devices. So how you are trying to access the data. Okay, so data is normally stored in the operand. So how any instruction will try to fetch the data from any operand. So this is the definition, is that the addressing mode is try to define the way of accessing the data from the operand. Okay, so now come to the point on here. There are different ways. So we normally talk in it, especially I am coming to the one type of processor is called 8085 microprocessor. In 8085 microprocessor, there are various type of addressing mode. So first we will call it as a register addressing mode, register direct addressing mode. Second one is called register indirect addressing mode. Third one is called immediate addressing mode. And the fourth one is called we can say direct, indirect, immediate, and we can say the implicit, or we can say implied addressing mode. And the last one is called as register addressing mode, because because here I done the classification like this. I taken indirect and direct mode directly at the top. So now we will talk about the first and very easy one, is called immediate addressing mode, because we will start in this way. So immediate addressing mode. Okay, for example, if I am having the one instruction for 8085, I'm saying we can take the example like this, MVI A32H. Okay, so what we are again, I am having one data. I am having this one data with me. So I am trying to store this data without taking the reference of any register or register pair into register A. Okay, so data is directly available to me. I am indirectly trying to store this data into the register A. So after this instruction, if I want to see the content of this one, A will be having the value of 32H. So definition says that if you are having any data, you can immediately fed that data into either any register or any register pair. So the I itself stands for immediate, MV stands for move, and I stands for immediate. Okay, and another type of, for example, we can go to the next one, just like LXI B comma something like 3000H. Okay, so when this instruction will be executed, you are trying to store this 3000 value into register B. So you can, when you store, the B will be having the value of 330 and this will be having the value of 0. So like that. Okay, so this is called the LXI B30. So this also stands for the immediate addressing mode, because you are not immediate. Why it is called immediate? Because you are having this data, you are having already this data in your hand. So data is available here. So size of data is 16-bit. Here the size of data, size 8-bit. Okay, so 8-bit data can be stored into the register, 16-bit data can be stored into the register pair. So automatically you can see on that the data is directly stored into this one. So immediately you need not to store it anywhere. You can directly, the programmer can directly feed this data into either register or register pair. And similarly, when we talk about some arithmetic and logical instruction, for example, if you want to add this instruction, just like ADI 45H. So the meaning is that what this instruction will do, this instruction will try to do this type of operation. Okay, so you are immediately adding that content. This, for example, you are having some data and this data is not stored into any register or register pair. You are directly adding this data into the accumulator itself. So this is called the immediately. Immediate means you need not to store it on either on any register or register pair. So you can take any logical instruction also, that for example, if I am having XORing, so if I am writing XRI 89H, so another type, this is also called immediate addressing mode. So this will try to perform the XORing operation. The A itself will be XOR with the 89H. Okay, so all these are called immediate addressing mode. If anybody will ask you that what is the addressing mode, it's called immediate addressing mode. Okay, if I go to the one type of mode, another type of mode is called register addressing mode. So in the case of register addressing mode, for example, we can try to understand from example first, and then I will try to give the definition. I am already having some data, just like move A comma C. So I assume that this C is having some data, and this data you want to move into accumulator. Okay, so this addressing mode is normally called as a register addressing mode. Okay, so you are having the one data, means data, if the data is stored into some register and you want to directly store this data into, or you want to move it into the some other register, you can move it with the help of this one. For example, if I am saying about the move if I want to do addition, I can do the addition with the help of the next instruction is that I say add h. So if I am writing the add h, the meaning of add h is that your a value will be added with the h value. Okay. So if you are having the some data into the h, you are trying to addressing this data. Okay, so you are performing some addition operation, so directly age data will be added with this one. So the meaning on this, why it is called as a register addressing mode, because you are trying to access the data from any register. You are already having the some data into the age, a is already having some data. Okay, so this data will be added with this one. Okay, so if I go for some logical operation, for example, if I am writing just like ORA B, so this will perform the ORing operation just like A is equal to A, it is value of OR with the B. Okay, so it's having the some data, B register is having the some data. You are trying to perform the ORing operation of this B data with the accumulator. So the ultimate thing is that whatever thing you are doing with the register to register. That's why it is called as a register addressing mode. So this register addressing mode can be defined into two different ways. This register addressing mode can be defined in a two different way. It is called either direct or it is called as an indirect. Okay, so the examples of the direct we have given into this one. For 16-bit, we can think about that. If I give the example of direct register addressing mode, if I am writing the some instruction just like STA 3003H. First, we will try to understand the meaning that what is the meaning of this STA. So this STA will try to store the content of accumulator on the memory location 3000. Okay, so now come to the point on here. Accumulator is having some value. I want to put it on the some memory location, and that memory location is 3003. So data is transferred from a register on the memory location. Okay, so if this memory location is fixed, it is given into this instruction. So we have seen in the earlier that you can either access the value from any register to register, or you can access the value from any register to memory location or memory location to register. For example, the reverse of this instruction is called LDA 4509H. So meaning is that some contents are available on 4509H. If I draw, so for example, this is your memory and some data is available just like FB. So this is your data. So this instruction says that go to this memory location and load the value into this one. So this, after the execution of this instruction, your accumulator will be having the value of FB. So ultimately we can say that this operation is performed with the help of some register. So what is the register on here? Is a register accumulator A. Accumulator A. So, and how you are accessing them, how the data can be accessed from this memory location. For example, if the data is available on 3000, you are trying to store that data like this. So your data is transferred from here to here on this memory location. From here to here, your data will be transferred from here. Okay, so in this case, you are accessing the data from the accumulator. You are accessing the data from the memory location, but the way is indirect. If I am writing something like like this, register indirect. Okay, for example, if I'm writing the one instruction for 8-bit is called move b comma m. How I can say what is the value of m? At what memory location the aim is pointing? I don't know, because this says that you have to initialize the aim. Okay, so and the condition says that first you have to initialize the aim by with the help of some HL pair. You have to give the some address and then you can access the value from this. So here I don't know what is m. So for m it will go to the some pointer just like LXI H9000. Okay, and from 9000 if there is a content is available on the 9000, the final content will be stored. For example, if I draw the pictorial representation for the same, it is having C0H. Okay, so for example, if I am directly writing this instruction, this instruction is register indirect. Okay, because I am writing move b comma m, so obviously it is register because m is also considered as a one type of register. So now come to the point on here. This m will try to search that what is the value of address. For this it will contact to the HL. HL is having one address as 9000H, and obviously it is having the some content just like C0H. So after the execution of this, the B will be having the value of C0H. So this is the indirect. So for any type of instruction, wherever the aim is coming, for example, if I am saying sub aim is also register indirect, we can go into some different way, just like move C comma aim, or we just the inverse of this, we can go move aim comma C. Both are indirect. So whenever the aim is coming, this is the indirect way. There is another way of indirect way is called, we are having some instruction just like LDAXB. Sorry, LDAXB. Load accumulator, X stands for indirect and B. So ultimately we can see that when this instruction will be executed, how this instruction will be executed. The instruction will be executed that it want to load the accumulator with the content given by the BC register pair. So by giving this instruction, I will say I am giving an indirect instruction to the microprocessor, because for the operation it says that you hit where is the value. So obviously it will search the some this LXI B type of instruction. For example, if I am saying I am having 9FFD, so at the 9FFD I am having the one value is just like 45H. Okay, so when I give LDXB, obviously it is indirect because it will search where this is instruction LXI B9FFD. Okay, so what I will say that when this instruction will be executed, the accumulator value will be value pointed by this BC register pair. Okay, BC register pair, and this will be having the value of 45H. Okay, and just the reverse of this one is STAX RP, obviously. So it is an indirect way of register accessing. Okay, I hope that it is clear to all of you. You can search, you can point to any instruction and you can think about that this may be direct or indirect, just like this one. Okay, for example, if I'm asking you the one question is that, can you please say that what is the addressing mode of this? If I'm saying that D, that say it is having 16-bit so addition directly. So now we can say the syntax for this one is that the HL pair will be added with the HD like this. So H equal to HD. Now we can say that HL, ultimately we can see this, the operation will be HL equal to HL plus DE. Okay, is it clear? So now come to the point on here. Can you please tell me the addressing mode of this instruction? What is it? This says directly add the value. So the obviously, as the word is coming direct, so it will go, obviously the HL will be having some value initially defined by the some instruction. So it will go to this HL and finally it will try to add with the DE. So the addition is performed directly. Okay, so this is called direct addressing mode. Direct addressing mode. And the type of mode is called register direct addressing mode. Okay. For example, if I am saying that something like JMP B000H. Okay, so jump immediately B0. So it is again called as a direct addressing mode. Direct addressing mode. Okay, so one in both the examples of direct addressing. One more addressing mode that is we'll try to discuss on here is that we call this one as a implicit oblique indirect implied addressing mode. Implied addressing mode. Sometime you have seen the instruction just like RAL, rotate the accumulator left. Okay, in this case you can see there's a opcode is available and there is a no operand. Operand is available inside to the opcode itself, because we can think about that it says that rotate accumulator left. So we can think about that, rotate accumulator left. Okay, through carry. The ultimate is definition is this. Okay, so it says that some data is available, some data is already available into the accumulator. Okay, so it says that operand it is itself available into the opcode. Okay, and you have to perform the rotate operation, you have to perform the operation of left rotate. So whenever you are seeing this type of the instruction, they are always follow the implied or implicit addressing mode. Okay, so we can think about that. There are so many instructions. We have seen that for example, this return type of instruction is called return when there is a 0, return there is a no 0, return like this, any type of thing, return when the parity is even, just like this. Or we can think about that there is a one instruction is called STC. Okay, XJG is the same, exchange instruction is also having this addressing mode. Okay, and the next thing is called XTHL is also having this one. So like this we can say there are various type of addressing modes is available for 8085 microprocessor. So one by one we will go into the depth. So may possible that we will go into the detail of much more addressing mode. But the point on here is that you should be aware about this addressing mode. So we have seen that 8085 microprocessor normally support the 5 type of addressing mode. The first one is called register addressing mode, which can be classified into the register direct or register indirect, then the immediate addressing modes, and the last one is called implicit or implied addressing modes. Okay, so whenever you are reading any instruction, I will tell you one more important point on here. Whenever you are learning any instruction for any processor, first point on here is that important points first you have to think that how many byte instruction, second thing you have to see on there is that after you are looking at this, how many machine cycle, if you know the machine cycle, then you can easily go that how many T states supported. If you know the T states, finally you are able to calculate the execution time. Okay, because the T states is directly relevant with the execution time, that how much the execution time any instruction is taking. The fifth very important thing whenever you are learning any instruction is that what type of addressing mode, supported by this one. Okay, so I'm not saying for 8085, you can go for any type of processor. So important point for learning any instruction. Okay, so I'm stopping here. In the next lecture I will try to say you some more example for that. Okay, thank you. So we can conclude this lecture by giving the definition just like the addressing mode. So the addressing modes is called the way in which the operand is specified in an instruction. It's called the addressing mode. The simple, we can say that if you want to discuss addressing mode with somebody is, then you can say that you're trying to search where the data is placed and how you are trying to access the data within some instruction. So this is called the addressing mode of any instruction. Okay, there are 5 types of addressing mode supported by the 8085 microprocessor. The first one is called as a register addressing mode. Another one is called as a register direct addressing mode, register indirect addressing mode, immediate addressing mode, and the implicit and implied addressing modes. The important thing is that the definitions of these addressing modes. Okay, so now come to the point. The first type of definition is called register addressing mode. We have seen the example of register addressing modes in my last tutorial. So we can think about that. In this mode, the operands are the register of the microprocessor. We can see that the 8085 microprocessor supports the various type of 6 general purpose register B, C, D, E, H, L, and A is also one of the register. So the thing is that the data, I am saying, the data is available inside any of the register and you are trying to use this register to access this data. Okay, so this may be anything, either you are moving or doing some arithmetic operation or the logical operation or anything you are doing. If you are doing with the help of some given registers which are available into this one, is called as a register addressing modes. Okay, another way is called the register direct addressing modes. In this case, what will happen is that it is called the direct, means you are trying to access the some memory. The first thing is that you are trying to access the some memory and you are directly trying to access the some memory. Either you are loading the some content into the memory or you are trying to take the some contents from the memory. So now come to the point. The definition is given that in this addressing mode, one of the operand is the data stored into the memory and the memory address of the data is directly given in the instruction itself. I will give you the one example is that, suppose for example you are having LHLD 3900H. So at 3900H some data is available. So if I am giving the instruction LHLD 3900H, finally that data will be directly copied into the H and L, because it will take the two addresses 3900 and 3901H Okay, so 3901H data will be copied into the H and 3900 data will be copied into the L. So this is the direct procedure. Okay, while if it is happened just like that, initially you have defined the we can say some memory location by using some register pair, and then ultimately you are indirectly trying to access this data with the help of some instruction. I will give the one example, just like you have given the instruction just like LXI 4000H. Okay, so some data is available at 4000H, and then next instruction you are giving that does the instruction just like move a comma m. So M is coming. So M will try to search where is HL and what is the memory location. So this is the indirect way. Okay. Or we can say if the instruction set is just like, we can return just like LXI H3900H, and the next we are giving LDXB. So ultimately it is not possible, because thing is that you have initialized this one with the HL and you are trying to access this one. So you have to give the correct sequence of the instruction just like LXI B 3900H, and then finally you have to give LDXB. So LDXB will show you the indirect addressing mode, because you are trying to load the contents from a memory location shown by the BC into the register A. Okay, but LDXB never show you what is the actual address. For this, it will take the reference of LXIP. So this is called the indirect addressing mode. So LDXB move wherever the aim is coming. So it is called the indirect addressing mode. Next one is called the immediate addressing mode. In this mode, the 8-bit or 16-bit data is given in the instruction itself. Okay, so we have seen all the types of instruction just like this. Okay, so LXI B49 just 3900H is also called as an immediate addressing mode. Okay, and LDXB is called register indirect addressing mode. And the last one is called as implicit or implied addressing mode. In this mode, what will happen that sometime you have seen the instruction where the operand is not available. The operand is clubbed inside the opcode. Okay, so we can say the operand is hidden inside the instruction. Okay, so this type of addressing mode is called as an implicit addressing mode. Okay, so guys, please if you are trying to understand any instruction for any processor, please try to understand the nature that how you are trying to access the data from this instruction. Okay, on the basis of this will give you the clear understanding that what type of addressing mode supported by it. Okay, so thank you so much. We will meet for the next type of addressing mode of 886 microprocessor. Thank you.